হ্যাঁ, গুড মর্নিং ম্যাডাম।
হ্যাঁ, গুড মর্নিং। শোনা যাচ্ছে তো?
হ্যাঁ ম্যাডাম, শোনা যাচ্ছে।
আচ্ছা,
স্যার আরম্ভ করবেন মিনিট 10।
ম্যাডাম আপনি বললে আমি স্যারকে দেবো, স্যার আর তখন আরম্ভ করবেন।
মিনিট
ঠিক আছে, বলুন।
আর ম্যাডাম আমাকে একটু স্লাইড শেয়ারের পারমিশনটা দিয়ে দেবেন।
হ্যাঁ, সবগুলোই দিয়ে দিচ্ছি, আমি করে দিচ্ছি।
হ্যাঁ কেপিজি স্যার, আমি বলছি, শুনতে
দাঁড়ান
পাচ্ছেন?
স্যারকে দিচ্ছি, স্যারকে দিচ্ছি। দাঁড়ান।
হ্যালো, গুড মর্নিং।
হ্যাঁ গুড মর্নিং স্যার, এক্স্যাক্টলি at 11:30।
এক্স্যাক্টলি at 11:30 স্যার শেষ।
একদম কোনো কারোর
হ্যাঁ।
জন্য wait করতে হবে না।
Thank you,
ম্যাডামকে আমি বলে দিয়েছি 11:30 মানে 11:30।
ওকে, থ্যাংক ইউ স্যার।
হ্যাঁ
আমি
ঠিক আছে।
মিনিট 10 বলবো, তারপরে আপনাদের।
হ্যাঁ তার মানে আমাকে শোনা যাচ্ছে, বুঝতে পারলাম। এবার
হ্যাঁ,
আমাকে আমার ক্যামেরাটা বাজে, আমি চালালাম, কিন্তু একটু পরে এটা
না, বোঝা যাচ্ছে পুরোপুরি।
হ্যাঁ এই
ক্যামেরা
দু
ঠিক আছে।
মিনিট 2 মিনিট পরে বেগড় বাই করবে, আমি বলে দিচ্ছি।
আই সি।
আর স্যার, আপনাদের দুজনকেই আমি কো-হোস্ট করে দিয়েছি।
ওকে,
সুতরাং স্লাইড শেয়ার বা অন্য সবকিছুই মানে অন
পোস্ট
থাকবে।
করে দিয়েছেন
হ্যাঁ।
ম্যাডাম আমাদের, কাজে
ঠিক
তোর
আছে।
কোনো তো অসুবিধা হবে না। ওকে, প্রথমে স্যার
আচ্ছা, আমার স্ক্রিনটা ম্যাডাম একটু ছোট, এটা বড় করবার কি উপায়? স্ক্রিনটা খুব ছোট্ট দেখাচ্ছে আমার, এনলার্জ করেও দেবো নাকি?
মানে ওই লাস্ট
না,
ডান দিকে
না,
ওই ভিউটাতে গিয়ে
গেল। হ্যাঁ কি বলছেন ডান দিকে?
ওই ছোট ছোট কয়েকটা ডটস আর ভিউ লেখা থাকে না, ওই ভিউ মোডটাতে গিয়ে।
হ্যাঁ ভিউ আছে, ভিউতে কি করব? হাইড, ফুল স্ক্রিন।
হ্যাঁ, ওখানে ফুল স্ক্রিন।
হ্যাঁ পেয়ে গেছি, হয়ে গেছে। পার্টিসিপেন্টস 14 মানে -3, 11। আচ্ছা স্টুডেন্টস, ক্যান ইউ হিয়ার মি? আর বুম্বা, তুমি শুনছো?
ইয়েস বোম্বা।
হ্যাঁ বলুন।
11:35 এ একটা অ্যাটেন্ডেন্স লিংক শেয়ার করবে, তারপর
আচ্ছা।
একদম শেষে আমি বলবো।
হুম,
আর মধ্যখানে স্ক্রিনশট নিতে থাকবে।
ঠিক আছে স্যার।
পিকেডি স্যার চেয়েছেন, এগুলো আমি দিয়ে দেবো সব।
ঠিক আছে, ঠিক আছে। ফার্স্ট এটা হবে, তাই তো? ঠিক আছে।
কি ঠিক আছে করছো, আমাকে বলছো কিছু?
না, আমি স্যারের সাথে কথা বলছি, স্যার।
তাহলে আনমিউট, নিজেকে মিউট করো।
ঠিক আছে।
আচ্ছা ম্যাডাম, সব স্টুডেন্ট মাইক এখন মিউট করে রাখুন, উল্টো পাল্টা সাউন্ড হবে। আচ্ছা, who is the gentleman visible on screen? Is it Mr. Soham Datta? Who is the gentleman visible on screen? Soham Datta?
Yes, sir.
There is somebody else, I think Nirlop Saha, I don't know. You see, the point is that this is a very formal class. It is not a informal class. So everybody must have a formal profile picture, which is like what you have in your ID cards. Not, picture taken in a shopping mall or on top of a car. So please do it in the next meeting onwards. If you can do it now, it's fine. A nice small passport picture is good. What you had in school or something. I will share a note in this year's batch. Formal meeting is formal meeting. Is Nirlop Shah, are you wearing a blue shirt and appearing on screen?
No, sir.
Yes, H21.
Yes.
Yeah, why are you using this kind of a profile picture? This is a IM meeting. It is a formal meeting. So you should have a formal small picture.
Okay, sir. I'll change this.
Please do it. I mean, I'm surprised you haven't done it now, as of now. You're already getting into second year. I did not notice this earlier, otherwise I had have made a comment earlier. Okay. কেবিজি স্যার শুনতে পাচ্ছেন?
স্যার দিচ্ছি স্যার, কেবি স্যারকে।
হ্যাঁ, দাও দাও।
Yes.
স্যার শুনতে পাচ্ছেন?
হ্যাঁ স্যার, হ্যাঁ স্যার। স্যার
ওই 4 মিনিট পরে শুরু করব।
হ্যাঁ স্যার।
বোম্বা 11:35 একটা অ্যাটেন্ডেন্স লিংক শেয়ার করবে, 35 বা 40।
11:40 অ্যাটেন্ডেন্স লিংক শেয়ার করবে।
হ্যাঁ
হ্যাঁ স্যার, I have told you.
40, ঠিক আছে।
জাস্ট ডট 11:30 স্টার্ট করবে।
একদম ডট, কোনো ইয়ে নেই।
Okay,
29 থেকে যে 30-এ ঢুকবে স্টার্ট করবেন।
ওকে।
Punctuality is something with which we can never compromise.
এক্স্যাক্টলি স্যার।
Ipshita has joined, ঠিক আছে।
প্লিজ। সাইলেন্ট।
আমায় শোনা যাচ্ছে ম্যাডাম?
হ্যাঁ স্যার, একদম ঠিকঠাক শোনা যাচ্ছে।
আবার স্ক্রিনটা ছোট হয়ে গেছে, একদিকে ডান দিকে চলে গেছে, এবার কি করি?
না, এটা বোধহয় যে পিপিটিটা ওপেন করছেন ওই স্ক্রিনটা দেখা যাচ্ছে বলে বাকিটা ছোট হয়ে গেছে হয়তো।
স্ক্রিনে তো আমি তো আমার স্ক্রিনে কিছুই দেখতে পাচ্ছি না।
কিছু দেখতে পাচ্ছেন না? ও
না, আমি তাহলে পিপিটিটা খুলে না অফ করে দিই।
হ্যাঁ 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 হ্যাঁ, পিপিটিটা আপনি এখন আপাতত অফ করে রাখুন।
আমি মানে বিদায় করে দিচ্ছি। এবারে কি করব? হ্যাঁ, আবার আসছে, ঠিক আছে।
ও আচ্ছা আচ্ছা, আপনি ওইটা অন করেছিলেন বলেই ওটা দেখা যাচ্ছে না। ওটা তো এখন দরকার নেই স্যার, অফই থাকুক আপনার।
না না, আপনি রোল করুন, ঠিক আছে।
হ্যাঁ হ্যাঁ
30 সেকেন্ড হবে।
হ্যাঁ, আপাতত এই যে ঋত্বিক দেখাচ্ছে, তারপরে
এটা নয়, এটা নয়।
স্যার আপনি স্ক্রিন দেখতে পাচ্ছেন?
আহ,
হ্যাঁ, এটা
হ্যাঁ,
এটা
screen
দেখতে
দেখা
পাচ্ছি, কিন্তু এটা কারেক্ট
ঋত্বিক
পিপিটি নয়।
তোমাকে যেটা পাঠিয়েছিলাম ইয়েতে হোয়াটসঅ্যাপে সকালবেলা।
হ্যাঁ, এরপরেই চলে আসবে ওটা, এটা নয়।
আচ্ছা আচ্ছা, ঠিক আছে স্যার।
এরপরে 2-1 মিনিট বাদেই আমরা উইল মুভ ইট।
আচ্ছা স্যার,
বলে দেওয়া
ঠিক আছে,
দরকার।
ওকে স্যার।
একেসি যেগুলো লিখেছেন দিস আর এক্সট্রিমলি ইম্পর্টেন্ট। আই রেড
হ্যাঁ স্যার, আপনি বলতে চাইলে অবশ্যই বলুন, কোনো
কিছু
অসুবিধা নেই।
ইম্পর্টেন্ট পয়েন্ট বলতেই হবে ওদের।
হ্যাঁ হ্যাঁ
Although it is with them, but you should say.
না স্যার, it has taken a tremendous amount of
Labor,
Again.
that I have understood.
tremendous amount of who is
Yes,
talking?
hours after hours we have spent for that. That I have understood after reading it very thoroughly.
हाँ तो उससे घमौरी होगा, तुमको ऐसा करेगा।
Yes, let's start.
सच बोल रहा हूँ।
Very good morning.
স্যার একটু নিজেরা আনমিউট করে নেবেন, আমি ওই সবাইকে মিউট করে দিলাম।
Okay. Okay,
হ্যাঁ
could you hear me? Could you hear
হ্যাঁ
me?
হ্যাঁ হ্যাঁ, একদম
Okay.
একদম।
Very good
Alright.
morning
ওকে
to my dear students. Online classes are taken by Professor AKC, Professor Sharmishta Ghosh, and KPG. Now, it is very important to understand that you have given the math exam and you have understood your errors. You have also somehow dismissed
স্যার,
this.
excuse me স্যার,
হ্যাঁ,
এটা নিয়ে এক্ষুনি বলার দরকার নেই, জাস্ট পিপিটিতে চলে যান, সময় পাবেন না।
আমি
প্রায়
একটা দুটো বললেই চলে যাচ্ছি স্যার, আমি জানি স্যার। একটা সেকেন্ড আমাকে টাইম দিন স্যার।
ও বাবা, ঠিক
Just
আছে।
a minute, sir. Please, please, sir. Now, the AKC has written very good points. These are extremely important for you. Please go through it very, very deeply. Otherwise, it will be very, very difficult for you. Please read all these things carefully, each and every word. I tell students each and every word. AKC has spent lots of hours for it, for your own development. It will not only help you, but also will help the examiners so that they can evaluate the scripts. Go to total, not next, but the new, that PPTs, math PPTs. Okay. If you read it very deeply, you can understand. We have no time, therefore you cannot discuss with it. But each and every words of AKC of the previous PPTs are extremely important. In this PPT, today we'll learn totally about D operator method. You can easily understand that what is written in general form of any total linear differential equation is this: A0 is identically not equal to 0, and big X as a function of small x, and that is present, and this creates particular integral. General
আমার কাছে কেবিজি স্যার, 1 second.
Yes,
Up to slide 16 has been covered in the last class.
up to slide 16.
17, 16, 17 এ straight চলে যান। Shomishta madam, please put the right slide.
You should tell me. That is up to this. From this we start.
হ্যাঁ, এটাও হয়ে গেছে, এটাও হয়ে গেছে।
Next.
আচ্ছা, আপনি এক কাজ করুন, এটাতেই স্টার্ট করে দিন।
Okay, let's start.
আগেরটা, হ্যাঁ,
Yes,
এখানে
from
start।
this.
তাহলে
Okay,
হ্যাঁ,
1
এটা
or
start
2
করুন।
minutes. Now, from this, you understand, depending on the form of big X and depending on the form of 1 by FD, my particular integral will change, which will be discussed by the professors. As big X may have 7 or 8 form, and 1 by FD have got many forms. First is 1 by FD, I write D minus A big X. Big X is a function of small x, which is independent variable. Answer is simply e to the power ax integral e to the power minus ax big X dx. Therefore, to do it, as we have discussed, you have to remember integration by parts formulae. If big X equal to sin x, you can easily remember, understand, I have to go to e to the power ax sin bx dx. And it is highly important to understand if a equal to 0. If a equal to 0, we realize e to the power x, anything to the power 0 is 1. In the integral sign e to the power minus x, it is also 1. Therefore, 1 by d, big X is nothing but integration. As d stands for differentiation, 1 by d stands for integration. It is done in a very clearly and nicely. Next. Sir will discuss that as told when a equal to 0, as I am discussing, 1 by d big X equal to integral of big X dx. This shows that if d stands for differentiation, 1 by d stands for integration. Many things are there. The problems will be discussed by Professor S.G. and Professor A.K.C. Then many problems are there. And again, you see 1 by phi d form to do the 1 by d square minus 3d plus 2. This is x e to the power 2x, that is vx into x, 1 plus fd form. You can do it, and also you can factorize it, and then 1 by d minus a big X form you can do. Sir will discuss. Next. At this junction, particular integral as told, in 12 we have find out the complementary function. If you add both of them, you are going to get the general solution, which is another condition of linearity, which you have understood in your electrical engineering. E to the power x formulas are there. E to the power x 1 by ft, e to the power x, e to the power x by fa, provided most important condition is written, fa is not equal to 0. If another is important, if fa equal to 0, then x e to the power x by f dash a. That means ddx you are doing fd and then put fa, d is replaced by a, again provided, very important, f dash a is not equal to 0. And if f dash a equal to 0, 1 by fd e to the power x, x square e to the power x, f double dash a, and again f double dash a is not equal to 0. In this way you can go on. There are 7 or 8 types of big X, and depending on it, the whole thing will be taken by Professor S.G. and Professor A.K.C. Therefore, I should give up the mic to Professor S.G. Professor S.G., please take over.
Yes, sir. Yes, sir. I will start.
Madam,
So, A.K.C. sir, with your kind permission, I will start.
Yes, I think with due respect to KPG sir, you can go back a few 2 or 3 slides.
Yes, sir. Yes, sir. I will.
And before you start, you can ask the students whether they have any questions so far.
Yes,
or
sure.
Anything to be repeated.
Sure, sir.
Slide আমরা যেটা সিলেক্ট করেছিলাম, we would start at 17, 18 ওই সব জায়গা থেকে একটু ধীরে ধীরে করুন. Sir has given a beautiful introduction. So now it is for them to go in details. Slide 16, 17 এ চলে যান straight away.
হ্যাঁ স্যার, আমি 16, 17 এ যাব, স্টার্টটা ওখান থেকেই করব. But just I want to where I am now, I think in slide 7, just to show the students the equation we are dealing with, just for 1 minute or few seconds, just to tell the equation we are dealing with. So students, KPG sir has given a nice introduction. Now let us start from where sir has left. But just to remind you that what we are doing, what we are learning in today's class, we are learning higher order linear equation with constant coefficients. So the basic form of the equation that we are learning, that is a naught dny dxn. So you have a nth derivative term, a1 dn minus 1 y dx n minus 1. A2, it goes on a n y equal to x. So this equation you have all seen in our last class as well as in our physical classes. But still once more to remind you that this is the equation what we are now learning to solve. As you can see, dny dxn appears. So this is a nth order equation and linear equation with constant coefficients. And your right hand side x, so this is a function of x. So right hand side is the, I hope you remember, this is the non-homogeneous term, and the entire equation, we call it a non-homogeneous equation. In the D operator notation, hope you all remember, D stands for ddx. So this is the form a0 d to the power n plus a1 d to the power n minus 1. It continues like this, y xx, or in a further shorter notation, we write it as f dy equal to xx. Because the expression within the bracket, that is now we can think it of as a function of d. Other than d, a0, a1, an, they are all constant. So it's a function of dy xx. So this is the basic format what we are learning and we would be learning. And it is a non-homogeneous equation as long as the right-hand side is non-zero. Now, at this moment, we should remember, again, these are some certain little repetitions just to start the class properly, that what we are going to do. Please remember that this non-homogeneous equation, actually, we cannot get the general solution for this non-homogeneous equation directly. There is no way, I repeat, there is no way to get the general solution for this non-homogeneous equation written in the form of 4 or 5 is not possible to get the general solution directly. So what is the way out? It is done in 2 steps, that we make first the right hand side 0, and therefore we get the corresponding homogeneous equation, and we find the general solution of the homogeneous equation. What did we call that? I hope you remember. That was called this complementary function, or YC. And next we find a particular integral of this equation 5. I repeat again, for the equation 5, we cannot get the general solution directly. What we can find is a particular solution. So what we do is we find a particular solution of this equation 5, which we write as pi, particular integral, or symbolically yp. And we find the general solution of the corresponding homogeneous equation, which we write as yc and call it as the complementary function, or in brief, CF. So everyone, first of all, are you clear with this point?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
So please see now, the CF part we have done thoroughly in the previous online class as well as in all the sections physical classes. So what we are left with is basically we started, but it was not completed, the part of finding the particular integral. So that is what we are going to concentrate today, finding the particular integral for the non-homogeneous equation. And yes, as you can see here, we have 2 methods. There are more methods rather, but as per our syllabus, we have the D operator method. Also, there is another one, method of variation of parameters, but we are not looking into this method of variation of parameters. Only we will concentrate thoroughly on this D operator method. So now the class will be concentrating totally on the D operator method. Okay, so and now I will skip and come to the next PPTs as AKC sir was telling. So please see here now that your equation, what we are solving, we are trying to find now the particular integral for this non-homogeneous equation f dy equal to xx. So symbolically, we can write the particular integral, our solution y, as 1 by f d xx. This form all of you have seen. So the particular integral yp, that will be always obtained as 1 by fd operating on xx. Now, please don't think that I have just divided by fd and I get y equal to 1 by fd xx. It's not like that, but 1 by fd is an operator, the inverse operator. Whatever job or task fd was doing, 1 by fd is the inverse operator. And what is that inverse operator? I hope some of you will remember. We had already done. Actually, even KPG sir told it now that 1 by fd is actually an integral operator. We know that fd is a differential operator. D stands for ddx. So fd is also in totality a differential operator. And 1 by fd is doing the reverse task. It's an inverse operator, and it is actually doing the job of integration. And as already shown by KPG sir, 1 by FD, 1 by D, just 1 by D is nothing but your integral operator. 1 by D is nothing but just the integration operator. As you see here, this was already shown. So this already was discussed by KBT sir. So I don't think I will go into this again. Now,
I have a question to ask the students at this
Yeah.
stage itself.
yes, sir, please.
So can I go ahead? Can anybody respond? If you know that 1 by D is the integration of a function, 1 by D applied on Y is the integral of Y with respect to X. Can somebody say, what is the meaning of 1 by D raised to the power of 2 operating on Y?
Sir, can I speak? It is a double integral, but basically we are integrating with respect to the independent variable once, then we are doing the same thing again.
Yeah. So please do not use the word double integral. Say it is a double integration, integrating the function once and then the result once again. So that is why, as KBG sir in the very beginning of the class said, please go through what I have written in another document absolutely carefully, because it has taken a lot of pain, a lot of recalling. Most of the papers I have corrected are in the college. So I just recalled all that I checked about a week back or so. Madam, please carry on.
Yeah. So students, as you see once again in the previous slide, we are trying to find the particular integral y, which is written as 1 by fd. This is the operator operating on the function x. Now, we don't have directly at the moment a formula for this. As we will see, we do have formula for 1 by fd xx for special form of x. Not for any function of x, I have a formula for you. But yes, we have special formula for 1 by fd of x when we have specific forms of the function. But before that, what we are seeing here, so just once more, just to remind you the formula, we don't have a formula for 1 by fd of x, but we have a formula for 1 by d minus a operating on x. So one thing you please remember, what is that fd? Fd is actually a polynomial in D. So if we can factorize it, we will have actually linear factors of the form d minus a. So this also can help us in finding 1 minus fd of fx. I don't have a direct formula for 1 by fd of fx for any fd, but I have a formula for one linear factor, so 1 by d minus a of x. And what is the formula? It is e to the power ax. This a over here comes here, e to the power ax, integral e to the power minus ax, the function capital X. X.
So my
Yes, I have muted them all. Sir, you can please unmute yourself. I have muted the students.
okay, thank you very much.
Yeah. So now this proof we are not going to do, but this proof is very easy actually, that because if I just take 1 by d minus ax equal to y, then it actually drops into a it comes into a just a linear equation. As you can see, dy dx minus ay equal to x, it just comes into a linear equation. We can solve and we actually get this formula. Now, I'm not going into details. You also don't need to prepare the proof for your exam. Only thing you have to remember this, 1 by d minus a operating on x is e to the power ax integral e to the power minus ax x dx. And more importantly, in case a is 0, please see, as a is 0, it reduces to 1 by d operating on x. A is 0 means e to the power 0 is 1. here this e to the power minus ax, that also has become 1. So please see that 1 by d operating on x is nothing but integral x dx. So we have told this already, but still I am repeating because this is a very important result. So from here, we are exactly clear that as we were telling, fd and 1 by fd are inverse operators. So you can clearly see, we know that d is the differential operator. 1 by d is nothing but the integral operator. So 1 by dx is nothing but integral x dx. Okay. So just some small problems first we have, and then we will go to the special cases. So the first one here is 1 by d minus 2 operating on e to the power 3x. So this is just a very small problem. First, I would like to say that this kind can only come in 2 marks. It's not a complete problem to solve a differential equation. It's just to find this particular integral 1 by d minus 2 e to the power 3x. So therefore, in our formula, the function x, that is here e to the power 3x, and the a in the formula, as you can see, that a is 2. So if I apply the formula on this 1 by d minus 2 e to the power 3x, I hope you remember our formula was e to the power ax. A is 2 over here, so I have e to the power 2x. Integral e to the power minus ax, so here it is e to the power minus 2x. Next is your function x, which is e to the power 3x, so we get this. Now it's very easy to calculate. E to the power minus 2x and e to the power 3x, of course, gives me e to the power x. And integration of e to the power x dx is, of course, again e to the power x. So e to the power x, and here I have e to the power 2x. Finally, my answer is e to the power 3x. So this is just a very small example to show the implication of the result, what we have discussed. 1 by d minus 2 e to the power 3x. Applying the formula gives us e to the power 3x.
Can I make a comment?
Yeah, sure, sir.
It is in the form of a question again to the students. Whoever can answer, please raise a hand. We'll unmute your mic. Would you add a constant to e to the power of 3x, or is it fine without a constant?
It is without a constant.
Why so?
As we
Why
are
so?
now
Say because this is a particular integral and
integrating is not like that type of indefinite integral at all. This is
Okay,
not
that's
that
very
of-
nice. You say the correct answer and complete answer is that we are looking at a particular integral which has 2 characteristics. Number 1, it is not derivable from the complementary function. Second, it is bereft of any arbitrary constant. Section IJK, who take my classes, I have discussed this in detail, so I think you don't have problems. Many others also in other sections know this very well. Thank you very much, madam. Please carry on. Madam, are you there?
Yeah, I'm muted. Yeah. Okay. So I hope this is okay with all. And now what is written in brackets, this is just a reverse action. You see, 1 by d minus 2 e to the power 3x is e to the power 3x. So if we do the reverse operation, the inverse operation, d minus 2 of e to the power 3x, if I apply d minus 2, if I operate d minus 2 on e to the power 3x, so if I do the inverse operation, operating d minus 2 on e to the power 3x, I am supposed to get, as it is here, e to the power 3x. This is just for a check. Not that you have to do this part if you get this question in the examination, but this is just for a check that yes, they are truly inverse operators. So when I apply d minus 2 on e to the power 3x, you can easily try that, and it is shown here also. If you do the calculations, you will get this e to the power 3x. Okay, so I go to the next problem. I hope students, you can talk actually if you want. So up to this, it is okay, or anybody has any query up to this, whatever we have talked up to this? Anyone?
No, ma'am,
No,
no
ma'am,
doubt.
it's fine.
Okay, fine.
Please ask questions up to this point of time, up to this point of time. ঠিক আছে. If you're fine, we carry on.
Yes, so we continue. So this is the next example. Again, a very short example. Once again, just to basically find the particular integral, 1 by d minus 1 x e to the power x. So that means the function x in our formula, that is now x into e to the power x. And obviously our a is 1. So once again, as we apply the formula 1 by d minus 1 x e to the power x, this becomes, we remember a is 1, so it is just e to the power x, integral e to the power minus x, because it was e to the power minus ax in the formula, so it is e to the power minus x, and our function capital X is x e to the power x. So this is the thing we get applying our formula. Now it's a very easy example because e to the power x and e to the power minus x gets cancelled. So I get integral x dx. And of course, if I integrate, I will have x squared by 2. So our answer for this, the particular integral in this case is e to the power x, x squared by 2. Right? And this is the part, if anybody wants, you can verify for the inverse operation. But if you get this question, this is the, up to this is your answer. And I repeat, of course, just finding this particular integral can come in 2 marks questions. But of course, this knowledge, please see, this knowledge will help us in doing the long questions where you will be asked to find the complete solution or the general solution of your non-homogeneous equation. There you have to do both parts, finding the complementary function as well as the particular integral. Okay, one more problem here is 1 by d square minus 3d plus 2x e to the power 2x. Now see, it's not of the form of 1 by d minus a, but it's a quadratic expression, isn't it? Quadratic polynomial, d square minus 3d plus 2, but we had a formula only for 1 by d minus a. So directly I cannot apply the formula, but of course I can do something. It's a quadratic expression. Of course, I can split it up. I can factor it and get the linear factors. So that is the extra task you have to do if you have a problem like this, where you have a quadratic expression. So you have to factorize this into linear factors. So please see that d square minus 3d plus 2. I hope all of you see that the factors are what? D minus 2 and d minus 1. I can write this d square minus 3d plus 2 as, so 1 by d square minus 3d plus 2, I can write it as 1 by d minus 2, 1 by d minus 1. But that is also not directly manageable. It may be, there is some way also, but anyway, but the better way is now is to split it like this. You can easily see that 1 by d minus 2, d minus 1. If you can do it just looking into the factors, it's fine. Otherwise, you need to do partial fractions basically when you have such product terms. To split it as sum of terms, you have to use the method of partial fractions. So if you do that, you see, I hope all of you can see that this is equal to this 1 by d minus 2 minus 1 by d minus 1. Because denominator, it is d minus 2, d minus 1, and numerator will be d minus 1 minus d plus 2. So numerator, you will get a 1. So please check if you have any confusion, please check on your own that 1 by d minus 2, d minus 1, we can write it as 1 by d minus 2 minus 1 by d minus 1. And it will be operating on our function x e to the power 2x. So now it splits up into 2 parts. 1 by d minus 2 operates on x e to the power 2x minus 1 by d minus 1 operates on x e to the power x. So basically we will apply our formula 1 by d minus a x 2 times. For the first one, our a will be 2. For the second one, our a will be 1. So for the first one, it is this one, a is 2. So e to the power 2x. Integral e to the power minus 2x, and the function x e to the power 2x. So once again, e to the power minus 2x and e to the power 2x, they are cancelling out. So integral x dx is x squared by 2. So this is the answer to your first part. I hope that is okay with all. And same way, the second term, same formula we are using, but now our a is 1. So it is e to the power x, integral e to the power minus x, x e to the power 2x. So this integration will take one more step basically. So here basically within the integral, what you're going to get? X e to the power x minus x and 2x will give you x e to the power x. So that you can integrate. Those steps are not shown here. So definitely you can do the integration and you will get the answer as written over here. Right?
But one comment with your
Yes, sir.
permission.
Yes, sir,
As
please.
KPG sir mentioned in the very beginning, that you must remember the integration by paths various forms. And I think I'm correct when I say that I have shared in the CR's group, and that has come to you, integrals of e to the power of ax cos bx and e to the power of ax sin bx. So integration by paths is something you will need quite often for doing the integrations. So please revise that. Thank you.
Yes, sir.
Ma'am?
Yes, sir. Yes,
ম্যাম
please.
এখানে যেমন x ইন্টু ই টু দি পাওয়ার 2x আছে, ওখানে যদি আমি ই টু দি পাওয়ার x স্কয়ার থাকতো তাহলে a ইকুয়াল টু 1 লিখতে পারতাম।
হ্যাঁ, e to the power মানে দেখো function x can be anything. In this case it is e to the x e to the power 2x. It could have been x e to the power x square. In that part you have to take care in the integration as just now Ekasi sir explained. So that এখানে যদি in case as you are asking এই ফাংশনটা যদি x e to the power x square থাকতো, I would have got something like this: e to the power x integral e to the power minus x, x e to the power x square. Yes, now the thing is that this total thing would have been, the total integration would have been more difficult because you will have now 3 terms: e to the power minus x tau thakbe, x e to the power x square. But definitely it's not that you cannot do. You have to take care more in the integration. It will take a little bit longer steps, but definitely you can do the integration and get your answer. So actually your function x can be any function of x. There is no restriction. Okay. Okay, so finally here, adding the 2 terms, the answer what we are getting is this one: x square by 2 e to the power 2x plus e to the power 2x x minus 1. So this is the total thing what you're getting.
There are some funny noises coming.
Yes, sir, I have muted them, or otherwise I will mute all again.
I think, madam, mute all.
Yes, sir. Yes.
And only when we ask specific questions.
Yes, sir. Yes, sir. Then only we
just
will
unmute the
yes.
mic, because you don't like this kind of disturbance.
Yeah. Yes, sir.
Ma'am, I have a question.
Yes, tell me.
ম্যাম লাস্ট টার্মটাতে আমরা তো দুটো ডিফারেন্সের আকারে রেখেছিলাম, তো যখন ফাইনাল আনসারটা দেখছিলাম তখন ওটাকে অ্যাড কেন করে দিলাম?
ও আচ্ছা, তাহলে just a moment.
Please talk in English.
Yes, ma'am.
Yeah,
I also have that same question.
That
we are
may be
adding
just a typo actually. It should have been minus. Okay. That is, thank you for pointing out. I think that is just a typo. It was minus, yes. Yes, so that when we are finding putting the result, I'll just rectify it. It will be minus. Thank you. Okay. Yes. Okay, so I just go now to the next thing. Now see, as we have seen in this example particularly, when I had a quadratic factor, I could not use that 1 by d minus a x formula directly. I had to do much of extra work to break it up into factors and then something more to again to split up as sum of two terms. So you can understand this is a second degree, it was a equation expression quadratic. If I have a d cube or d4 term, so using this formula will become more and more difficult. So now what we will learn is that we have actually some shortcut formulas. We have some shortcut formulas. That is what we are going to learn now. But the shortcut formulas do not exist for any arbitrary x. But yes, we have 5 basic formulas, 5 or 6 we can say, but mainly 5 for some special forms of capital X. And mostly we will see that those formulas suffice to do many of the problems because those will be some basic functions, very important basic functions as exponential function, polynomial function, trigonometric, particularly sine cosine functions. So we have formulas for some this kind of basic functions. So you have to remember in your mind, you have to memorize these basic formulas, and then we can apply the formulas and get the particular integrals more easy. So that is what now we are going to concentrate. Now the first one, so you see as written here, we are now learning shortcut methods for finding 1 by fd of x. So please see now here I can have any fd, any function of d. There is no restriction on that a linear factor or something. I can have any fd of x. But yes, for some elementary forms of this capital X. So the first one, which Kapiti sir already started, just I will repeat shortly and go to problems. So the first form is x is an exponential function e to the power ax, right? So please see, that means what I'm trying to find out is 1 by fd of e to the power ax. This is what, this is the particular integral we are finding out, 1 by fd of e to the power ax. Now see, what is the formula? It's very, very simple formula. It is e to the power ax. You have in the numerator, denominator in place of fd, now you have fa. That means whatever this expression you have for d, just you replace d by a and you get this formula, e to the power ax by fa. Just you are replacing d by a. Very simple formula, but there is a but. That can I write this always? I can write this only when the denominator is non-zero. So therefore, this formula is applicable only when fa is not equal to 0, right? So this is a very simple formula, e to the power ax by fa. You are just replacing d by a, but provided fa is non-zero. But then what happens in a particular problem if fa is 0? What is the way out? We have now the next formula, the generalized formula. In case fa is 0, what happens is you have again e to the power x, but you have one more x term. One x appears in the numerator, and denominator you see in place of fa, now you have f dash a. So that means now your fd, you have to first differentiate this. You have to calculate f dash d. So f dash a means what? F dash a means f dash d when d has been replaced by e. So your formula is x e to the power x by f dash a. So what you have to remember, you have an extra x, and denominator in place of fa, you have f dash a. That means you once differentiate the fd and then you replace d by a. But of course, now again, we will have a restriction. This formula will hold true only when the denominator f dash a is again non-zero. So this is the formula if fa is 0, but provided f dash a is non-zero. What happens then if f dash a is 0? F dash a is 0, I am not being able to write this formula b. So it is again modified. So again modified. Now the rule is very simple and easy to remember. You have one more x term. So you see now it's x square. So one more x comes. And the denominator you differentiate once more. So it is now f double dash a. So you are differentiating FD 2 times and then replacing D by A. Okay. Now you may say, of course, that now F double dash A also could have been 0. Yes. If it is 0, you have to continue in this manner as long as the denominator is non-zero. So as long as the denominator is non-zero, you have to continue. Every time, please remember, you get a x term and denominator, you differentiate once more, and then you replace D by. So this rule is clear?
Yes, ma'am.
Okay. So now we will see problems on this before we go to the next rules. This is our first case or first rule, and we see problems. So the question is, find the particular integrals for the following equations. We have two problems basically. So the first one, d square plus 1 y equal to e to the power x by 2. So please see that this is your FD. FD y equal to x, that is the general form. So FD is d square plus 1. So the particular integral will be written as, you remember, 1 by FD of x. So the PI, the particular integral, is 1 by d square plus 1 e to the power x by 2, right? So your FD is d square plus 1 and your x is e to the power x by 2. So e to the power x by 2, so definitely it is an exponential function. So our rule 1 will apply. So what is our a here? It is e to the power x by 2. So anyone can answer what is our a?
Ma'am, half.
A is half. Very good.
1 by 2.
Yes, ax, so a is 1 by 2 or half. So therefore you see, now I apply the rule e to the power x by 2. So whatever e to the power function we had, that remains. And the denominator, what we do? We replace d by this a. So a was half. So d is replaced by half. So it's half square plus 1. So it's 1/4 plus 1, or rather 5 by 4. So I put it up. So it is 4 by 5 e to the power x by 2. Okay. And now the next one.
Excuse me, madam.
Note.
One moment, bitte.
Yes, yes, sir. Please. please.
Ritik, are you there? Ritik,
हाँ सर, अच्छी सर, बोलूं.
please put an attendance link now.
अच्छा सर, कोई
Once
issue
again.
sir. हाँ सर, कोई issue.
এক্ষুনি দিন, তারপর আমি আরেকবার বলবো, হ্যাঁ?
ঠিক আছে স্যার.
ঠিক আছে।
Okay. Sir,
Madam,
I will continue.
ঠিক আছে। Yeah, you continue. The attendance link will come for a second time.
Yeah.
PKD has asked for all this, so I'll send it across.
Okay. So now see, students, the question was find the particular integral. This is done. But most likely in the examination, as I told you, only the particular integral, if this one comes, this can come in 2 marks. But maybe for a 5 marks question, you get the question to find the general solution or the complete solution to this equation. So that means in that case, you have to find the particular integral, as well as your first step was finding the, what was that? Finding the
Complementary function.
Complementary
the
function.
solution to the homogeneous
True.
equation. So homogeneous
Yes, ma'am.
equation means you will be finding d square plus 1 y equal to, just you are making this as 0. So you are finding d square plus 1 y equal to 0. So I hope all of you remember this. So you have to write what? The auxiliary equation.
Yes,
M
ma'am.
square plus 1 equal to 0. So your aim is going to be, what are the values of
Plus
m?
minus iota.
Plus minus
Plus
I.
minus iota.
Plus minus iota.
Right. So therefore, these are complex roots then, plus I and minus I. And I hope you remember, complex roots are not written directly. They are written in the form of e to the power ax cos bx plus I sin bx, that form. So your answer is going to be, as you see, it's 0 plus minus I into 1. So your a plus ib, a is 0 and b is 1. So the answer, the part to the complementary function is c1 cos x plus c2 sin x. I hope that complementary function part is okay with all. C1 cos x plus C2 sin x.
Yes, ma'am.
Okay. So therefore, the general solution or the complete solution to this equation A is C1 cos x plus C2 sin x plus 4 by 5 e to the power x by 2. Okay. Now I will go to the next one. That this is the question. D square minus 3d plus 2 operating on y is e to the power 2x. So as we are just looking for the particular integral, the particular integral pi will be 1 by d square minus 3d plus 2 e to the power 2x, right? So this is your fd now, d square minus 3d plus 2. So what we are looking for is 1 by d square minus 3d plus 2 operating on e to the power 2x. Okay. Now you see, if I want to apply our formula, it would have been e to the power 2x in the numerator and denominator will be fa. What is your a? A is obviously 2, e to the power 2x. Denominator would have been fa. Plus, now as you substitute 2 for d, you're replacing d by 2. You can easily see this is 0. If I replace d by 2, 4 minus 6 plus 2, so f2 is 0. Okay, so that means our rule 1, the case a fails. The direct application as e to the power ax by fa, that fails because fa, or in this case f2 is 0. So therefore we will go to the next rule. There, if I go back to this PPT, you see here I had written the basic one where fa is not 0 as a. When fa is 0, we have written as b. If further this becomes 0, we have written as c. So please see, rule a fails because fa is 0. So therefore we are compelled to now use the rule b. So what was the rule b? You will add a x and denominator will be f dash.
Derivative.
Yes, derivative. Yes. So therefore you see this 1 by d square minus 3d plus 2 e to the power 2x. I have this x, and now we first differentiate this. So if I differentiate this, it is 2d minus 3. So 1 by 2d minus 3 e to the power 2x. And now we are going to replace d by a. A, our case is 2. So I will replace d by 2. So 1 by 2 into 2 minus 3. So it's 1. So your answer to this particular integral is x e to the power 2x. Hope it's okay with all.
Ma'am, can you explain this once more?
Yes, see that the particular integral, what I have to find out is 1 by d square minus 3d plus 2 e to the power 2x. So it is of the form of like 1 by fd. My fd is this d square minus 3d plus 2 e to the power 2x. Now, our rule A, what it told us that first basic rule was that I can write this as e to the power 2x divided by, so e to the power 2x, that means a is 2, the coefficient of x is 2 over here. So we will write a to the power 2x by f2 if I want to use the rule A. But of course I can write this formula provided this f2, this denominator is not equal to 0. Now here we check. If I want to use this rule, I have to put the value of f2. And here as I check, I see that f2 is 0. You can easily check, you replace d by 2, this is becoming 0. So therefore this rule A fails. The denominator f2 is 0, so I cannot write it. So what is the modified rule? The modified rule was, I will still have e to the power 2x. Along with that, a x term will come in the numerator, and the denominator will be now f dash 2. F dash 2. That f dash 2 stands for what? F dash 2 stands for f dash d, where d has been replaced by 2. So first job is I have to differentiate fd. I will differentiate fd with respect to d. I will get f dash d, and then d will be replaced by 2. So therefore see that our rule A fails as f2 is 0. So I want to use this rule. So therefore I have this x. Actually x, we can write straight away like this, or normally actually x is outside. And now it is 1 by f dash 2 e to the power 2x. So first, we have not written f dash 2 directly. I have just first written f dash d. So I've written x f dash d. So if I differentiate this, you get 2d minus 3. So x 1 by f dash d e to the power 2x. So what I have written actually is first x 1 by f dash d e to the power 2x. And then next step, we are replacing d by 2. So next step, actually, I'm coming to here. First step, I have written this like this, that x 1 by f dash d e to the power 2x. And now we are replacing d by 2. So as I replace d by 2, I get this 2 into 2 minus 3. So it's just a 1. So we get x e to the power 2x. So is this okay? Whoever had asked?
Yes, ma'am, clear.
Okay. And now, next I have put a question for you. As here the question was just to find the particular integral. We have obtained the particular integral as x e to the power 2x. So that is over. But as I told you, most likely in the examination, say for a 5 marks question, the question will be not only to find the particular integral, the question will be to find the general solution, or rather the complete solution of this equation. So general solution or complete solution will mean pi plus CF. So please, you have to find that CF, and that I have written as try yourself. I hope you can do it. Can anyone tell quickly what will be the CF part? Anyone can try?
C1 e to the power 2x plus C2 e to the power x.
Very good. Because if you factor this, this is going to be d minus 1, d minus 2. So actually the roots are 1 and 2. So therefore your YC part, the complementary function will be C1 e to the power x plus C2 e to the power 2x. Okay. And one more thing, when we see answer scripts, you know that many students, you write the YC, you write the YP, but finally you forget to write the general solution or the complete solution. And if you don't write that, usually 1 mark at least will be deducted. So after finding the YC and YP, please remember to add YC plus YP to give the final solution or the complete solution. Okay. So please do not forget that, to write the complete solution YC plus YP. Okay. So next, I hope this is clear. Then I will go to the case number 2. The case number 2 is if your xx, the function on which we are operating, that is a polynomial function, a polynomial in x. It can be of any degree. So in general, we have written this as nth degree. So suppose that your xx, that when you are evaluating this 1 by fd of x, this x is a polynomial. Okay. Now, in this case, we don't have a particular formula like case 1. If your x is a polynomial, we have a general way to work out, a normal way to work out any problem you get, but we don't have a formula. So what is that? We will see basically with an example. What happens actually, this 1 by fd, we write it as fd to the power minus 1. This 1 by fd, like suppose I had a 1 by d minus 2. I write it as d minus 2 to the power minus 1. And then we expand using the binomial theorem. Up to, if your polynomial is of nth degree, then we will need to write up to the term d to the power n. So once again, 1 by fdx, where x is a polynomial, we don't have a formula, but we have a working rule. What is the working rule? We take this fd in the numerator as fd to the power minus 1, then use binomial theorem, expand this using binomial theorem, and then we will get the answer. So this will be clear only when I show an example. This may not be clear to you. So please see, this is the question. So once again, we are just asked to find the pi. So d square y dx square plus 4 dy dx plus 3y equal to x square plus 3. So the pi, so symbolically, first of all, you see this is d square. plus 4d plus 3 that we all know. So what we are searching for is 1 by d squared plus 4d plus 3 operating on x squared plus 3. So this is what is the PI to be found out. 1 by d squared plus 4d plus 3 x squared plus 3. So please see x squared plus 3. Definitely this is a polynomial in x squared plus 3. It's a second degree polynomial. So we are in the case 2 where your function capital X is a polynomial. So what do we do? As I told you, we will write this d squared plus 4d plus 3. We will write this as d squared plus 4d plus 3 to the power minus 1 basically. And then we will expand binomial. But how do we do that? So before we do the total thing, first we see how do I express this. Okay, so I think I'll go to the next slide. Yes, what we do here is just please see, I'm not now do the operation. I just want to express this 1 by d squared plus 4d plus 3. So what we will do first of all, see that this is a general rule for any problem. The constant term you take out, you see d squared plus 4d plus 3. So the constant term I take out, basically I need the form of 1. Actually, I will need this 1 plus x to the power n, this form of binomial, or maybe a negative power. Definitely we will get a negative power. We will get something like 1 plus x to the power minus 1. So basically this binomial formula we are going to use. So what we do is I need a form of 1 plus x to the power minus 1. That is why whatever is your constant term here, it's 3, maybe another example, it is 8 or whatever, you take out the constant term. So I get 1 plus the rest of the thing. So if I take out the 3, I get 1 plus d squared plus 4d by 3, right? Please understand this, the constant term is taken out and then I get this 3 here, 1 plus d squared plus 4d by 3. So 1/3 is a constant. I just keep it like this. And this 1 by 1 plus d squared plus 4d by 3, I write it in the form of 1 plus d squared plus 4d by 3 to the power minus 1. Please understand this is the general working rule for any problem you do with this when you have to operate on a polynomial. Okay. So
Madam,
please
one
see.
comment.
Yes, sir, please.
The comment is very simple. All students must get very familiar with the expansion of 1 plus x to the power of n when n is a negative integer or a rational fraction. Then the series on the right, the binomial expansion is infinite, is not a terminating series. So please get familiar with these expansions. It is found in any book on higher algebra, and the topic to look for is the binomial theorem for any index. Any index. Thank you.
Yes, sir. So thank you very much for this comment. So definitely students have to remember the binomial theorem formula. So here specifically what I'm going to use is 1 plus x to the power minus 1, treating this whole thing as x. We have put it into this form. 1/3 is a constant appearing and the rest is 1 plus this d squared plus 4d by 3 to the power minus 1. So we will treat this entire thing d squared plus 4d by 3 as x. So I will now apply the binomial theorem formula for 1 plus x to the power minus 1. So if you remember it well, if you don't remember, this is the formula: 1 minus x plus x squared minus x cubed. So plus and minus goes alternatively and the x power increases. And as sir told, when we have negative power, it is an infinite series. So it goes like 1 minus x plus x squared minus x cubed, like this. Okay. So as I write this, as I apply this binomial formula, we see that I have the 1/3, of course, outside. 1 minus x, so this is my x term, plus x square. Now, how long should I write? That I already told you, that if you have a polynomial of degree n, the maximum d power you will need is d to the power n, not more than that. Why? If you have a polynomial of degree n, nth derivative is always a constant. I hope you remember that in successive differentiation. If you have x to the power n, dn of x to the power n. Anybody can tell what is dn of x to the power n? Nth derivative of x to the power n?
Factorial.
N
Factorial n.
factorial, right? Absolutely.
factorial.
It is n factorial, so it is a constant. So see that if I differentiate once more, you will get 0, right? So therefore, it's always enough to write up to d to the power n term. We actually will not get finally an infinite series answer. It will be a finite one, because after d to the power n, all higher derivative terms will give you a 0. So basically, when you are writing the expansion, it's enough that you write up to d to the power n if you have a polynomial up to of degree n. Now, in our case, if you remember, our question was x square plus 3. So actually, it is enough if we write up to d square. So this one we have written. Of course, it gives you some d4, d cube terms also, but it gives a d square term also. So that is why I had to write this. But I need not write the next one, x cube term, because that will give the minimum d cube, which will be not needed. So please understand this, how long you have to write. So this is what we will write, and now we just simplify. So you see here, it's 1 minus, okay, d squared term I have to add up a little bit. D term, you see, it's minus 4d by 3. So it's minus 4d by 3. For the d squared term, you see, here I have minus d squared by 3. This is one term. And here also you will get one term, isn't it? Because when you expand these, you get d4.
ওটা 13 d square by 9 হবে মনে হয়।
At 13
It would be 13 d square by
12 plus 13 d square.
No, I will tell you,
Yeah.
there is indeed a typo in this slide. Please correct it yourself, okay?
Yes, yes, yes.
I was going through the slides this morning. I
Yeah.
found this myself, so whoever has made a comment is absolutely right. Nevertheless, check again and come to a conclusion which you can. Thank you very much.
Okay. So please see, these are just my typo thing. You can all do the calculations and see. So finally, you will get an expression like this, okay, which will involve some constant term d squared. That's it. The coefficient might be wrong, so please check it yourself, right? Okay.
And once you apply this, this FDA to this answer, if you do not get the original equation, then you're sure that there is a typo. So that
Yeah.
can be corrected. It's not a major this thing. Understanding the principles is much more important than a 2 or 3 or 3 written in place of 3 by 2.
So one thing I can
Okay.
see, this 4d by 3 whole square, this is going to be 16.
No, sir, madam, I've seen this. There is a typo.
Okay, sir, no problem. Yeah.
Please.
So that is just the coefficient may vary, but the form
এরপর
will remain the
টাইম
same.
পাবেন না, অলরেডি 12:30 হয়ে গেছে।
Yes, sir. Yes, sir. So now please see that this, whatever we have got, this is our operator, which will be operating on x square plus 3. So that is very straightforward. 1 by 3 constant remains here. Now 1 into x square plus 3. So that will come along. X square is coming, and plus 3, the constant will be there, but that perhaps definitely we have adjusted with other terms. So you don't see straight away the 3. Again, you have to do the calculations over here. So just see that 1 into x squared plus 3, this is going, you are going to write minus 4 by 3. D is operating on x squared. So ddx of x squared is 2x. So therefore, you are going to get minus 8x by 3, right? And obviously, ddx of 3 is going to give you a 0, no contribution. So you are getting this term. Now, had this coefficient been okay, anyway, you have to check. But anyway, what you have to do is you keep the coefficient, say 4 by 9. d square of x square. What is that? It's 2. So 2 into, so it's 8/9, and you had already 3. So anyway, so you have to just do the calculations and you will get an answer like this.
Ma'am,
Okay. Yes.
in this case, there is no concept of A.
A means what your,
ওই 1 minus D minus A ওই concept.
no. That we
This
are
is
not
something
using.
else. This is a different case, my dear friend. The first case is 1 over D minus A applied on X. Here, the FD is not of the form of D minus A, it is of the form of a quadratic, which may or may not be possible to split into partial fractions. So this is an entirely different case. Understand, when the PPTs go to you, please give a solid study. Already, I can see that only 160 some people are attending, but whoever is attending will get a benefit. Carry on, please, madam.
Yes. So as you have asked and sir explained, this is an alternate approach. If you would have tried to do with that 1 by D minus A, in that case, what do you have to do? It's a quadratic one. You have to factor like this, D plus 1, D plus 3. Then you have to use partial fractions to split it as sum of 2 terms. And then you have to apply. So that is another way you can definitely do with that. But sometimes it becomes lengthier because you have to split, you have to use partial fractions. So that consumes a lot of time. So using the formula is shorter actually. So that is why we are learning this ready-made formulas, which gives us shortcut methods. But if you can try the same with those 1 by D minus A formula, but that will give you some extra task. Is it okay?
You discover for yourself. Discover for yourself. Any problem can be done in 2 or 3 ways. You discover for yourself.
Yes.
By practice, you will be able to find out which is the shorter and the easier method. And sometimes the partial fractioning can be done by inspection. Okay, so that may become a short way. So you have to practice, just reading this like a novel in which Sherlock Holmes murders Watson. That's not the purpose of these PPTs.
Okay. So definitely you can try with that, and surely both the methods, some people had been asking me, both the methods or whichever method you take, they will definitely give you the same answer. You cannot get 2 different answers. Ways may be different. And as sir told, you find out which one is more comfortable. But these are usually shorter ways when we use directly these rules basically. Okay.
So ma'am, during exam, will it be looked in? Good afternoon, ma'am.
Yes.
Actually, during exam, will it be looked into which process we are using? Like if you found that this second process could be used in place of first one, but
No. As long as your steps are correct, no, I mean, there will be no other consideration. We will just look into whichever method you use, whichever you feel comfortable. If you still feel comfortable with that 1 by D minus A, you can do with it. You may not look into this specific cases, or if you are looking into these rules, whichever you feel comfortable, you can do. And definitely, if your steps are correct, your answer is correct, you are going to get full credit. No issues. Which formula you use? Okay,
ma'am.
Okay,
yes. Yes,
ম্যাম আগের স্লাইডে যে এক্সপেনশনের পরে যে সিম্পলিফিকেশন ওটা আপনি বলবেন?
দেখো এই পার্টটা, এই লাস্ট লাইনটা, দিস ওয়ান না এখানটা কোনটা? which one you want to ask?
হ্যাঁ ম্যাম 1/3 ব্র্যাকেটের আন্ডারে 1 - 4d/3 + 4d²/9 ওইখানটা।
দেখো এটাকে জাস্ট উই আর ওপেনিং।
ওটা আমি আনসার করে দিচ্ছি ম্যাডাম।
হ্যাঁ স্যার।
ওদের কোয়েশ্চেনটা এই জন্য হচ্ছে বিকজ ওরা বাইনোমিয়াল এক্সপেনশনটা জানে না। কাজে আপনি বলে দিন বাইনোমিয়াল এক্সপেনশন 1 ± x to the power of -1 ওটা দেখতে।
Yes, and actually I have written here in the PPT. You see, I have written here. This is the binomial formula we are using here. 1 + x to the power -1. This is 1 - x + x² - x³ like this. ঠিক আছে? তাহলে এই যে d square plus 4d by 3, this is what I am considering at x. So I have a form like 1 plus x to the power minus 1. So I have used this binomial expansion. So 1 minus x, my x is d square plus 4d by 3 plus x square. So it's d square plus 4d by 3 whole square minus, there will be more terms, but I am not writing the more terms. Why I am not writing that also I have explained, because function what we are going to operate, that is x square. So it's sufficient if I write it up to d square term. I don't need terms starting from d cube, because d cube of x square will be always 0. So polynomial, you look into the degree of your polynomial x square, so it's sufficient I write up to d square. So that is why I have not written any more terms from this binomial expansion. Now this one you have to just write and simplify. Just I have opened this and adjusted the terms. Like 1 is the constant term, is already here. Next I'm writing the d term. You see here I have the 4d plus 3. So minus 4d by 3 is coming because this is the minus sign over here. Now if you look into the d square term, I have a minus d square by 3. And if you open up this square, if you write this square term, from here also you will get a d square term. So this d square term and this d square term, this has been combined to write this d square term. So just do it yourself. Open this bracket, write the d square term and calculate what you are getting. So like this, we are simply expanding this. And now once we expand this, we are operating this on this x square plus 2. So just you have to do here again one term by one term, like 1 into x square plus 3.
Understand.
Okay, ঠিক আছে. Okay, so now I go to the case 3. We have 5 cases basically. So let me go to the case 3. So the case 3 is actually the rule is
So,
same.
madam,
Yes,
I'm
sir.
leaving for about 5 minutes. You
Okay,
see,
sir,
the
no problem.
AC repairman has come. I'll join after 5 minutes.
Okay, okay, sir, okay, no problem. So please see that this case 3, the function, 2 rules actually are combined here. The same, I mean, rule is same. If the function is a sine function or a cos function, your rule is same. So x can be sine ax plus b, or it can be a cos ax plus b. Both cases, the rule goes very similarly. So we have written here with the oblique. Okay. But now you have to be a little bit careful with this rule. You see, our form is 1 by fd of x. So your x is either sine ax plus b or cos ax plus b. Now, the rule is like this. Here, this function of d, first we need to express this as function of d square. Just we cannot work directly on d in this rule. Please see. Now, little bit remember your case number 1, when we had the exponential function. What we were doing in the denominator, we were just replacing d by a. But this rule, here we cannot do anything with d, but we can do with d square. So what we have to do is, first this function of d, I have to consider this as, I have to look into the d square term. So I have to consider this as a function of d square. Now, how would this works? We will see with examples. Maybe it may not be clear at this moment, but only thing, please remember, যে d কে নিয়ে কিছু করা যায় না, we can work with d square. ঠিক আছে? So this fd, I have to look into as a d square term. So function of d square, I assume that this is a function of d square. And then what the rule tells, that d square, you see, numerator will be the sine or the cosine function, whatever is your function. Denominator, phi d square jagah, what I am writing, phi minus a square. So what is happening here is, please note that d square is being replaced by minus a square. This is the main thing what you have to remember when you have this sine function or cosine function. that in this FD part, if you have a D square term, again I repeat that D ke kintu kichu korte parbo na. I cannot do anything with D. We cannot change D. D square has to be replaced by minus A square. Okay. D square can be replaced by minus A square. If any D is remaining, it will remain. We have to treat it otherwise, but I cannot do anything, change D. I can only change D square, and D square will be replaced by minus A square. ঠিক আছে? Now, one thing again, whenever I'm writing something in the denominator, I have to assure that this should not be 0. So therefore, this rule follows obviously only if phi minus A square is not equal to 0. Okay. So the rule is 1 by FD sine AX plus B or cos AX plus B. What is that? Numerator is sine AX plus B or cos AX plus B, whatever is the function you have. Denominator, it should be a function of minus A square, where you are replacing D square by minus A square, provided this is 0, not 0. Now then, what happens if this is 0? Here in the PPT, we have not written the subsequent cases, but please listen to me. It is the same thing as case 1. In case the denominator is 0, what was the case 1? You will have a x, extra x here, and here you will have a derivative. So in that case, you have to find out phi dash of D square, and then you have to replace D square by f dash D. Anything, you can differentiate FD also. You have to differentiate this. First, you have to differentiate, and then only thing is that not D, but D square will be replaced by minus A square. So please see, this part is same as rule 1. In case denominator becomes 0, you have to add a x in the numerator, and for the denominator, you have to differentiate, and then you have to replace D square by minus. Okay. So,
ma'am, will the function remain same? For instance, if we have sine AX plus B, if the denominator becomes 0, should it be x sine AX plus B divided by xi of minus A square?
Yes, yes, function remains same. There is no change in the function. Okay. Only you have to look into sine AX. What is that A? Denominator, you are using that D square by that minus A square. Actually, B also has no rule. Mainly this A is taking the rule, is the rule.
And we are taking the derivative of the D function in that.
Yes, 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 yes. We are taking the derivative. Okay. So let me take an example. It will be clear. So you see, find the complete solution to the differential equation D square plus 1y equal to sine x. So complete solution means we have to find the complementary function and the particular integral. So this part I think you know, because in another question also I just explained the same thing. D square plus 1 means you have the auxiliary equation as m square plus 1 equal to 0. So m is plus I and minus I, and the yc is then c1 cos x, c2 sin x. I just already explained. So mainly let us concentrate on the particular integral. So the particular integral is 1 by d square plus 1 sin x. Now see what I told you in the formula. D square should be replaced by minus A square. So what is my A over here? My function is sin x. That means A is 1, B is 0 basically. A is 1, B is 0, sin x. And as I told, B has no rule, mainly no role over here. Only we have to look into A. So A is 1. So as my rule says that D square should be replaced by minus A square. That means minus 1 square, or rather it will be replaced by minus 1. Okay. Now one thing, please don't get confused. It's not like minus 1 whole square. It's not like that. It's minus A square. Minus remains and A square. So minus 1 square. So basically D square should be replaced by, as you see, it is written here also, that D square should be replaced by minus 1 square. But now you see there is a problem. If I do that, this denominator is becoming 0. So as per the direct rule, if I replace d square by minus a square, so this denominator is becoming 0. So therefore, I cannot apply the direct rule basically. So I have to extend the rule. I have to modify the rule. And what did I tell you for the modified rule? That I will add a x over here, just similar, very similar as your case number 1. When the denominator becomes 0, I have to add a x over here. I have to differentiate. And after differentiating, if possible, I have to replace d square by minus a square. But first I have to differentiate. Okay. So see that I have added this x over here, and once I differentiate d square plus 1, I hope this is okay with all, that I get 2d, right? So once again, I repeat, because this is a little bit complicated than the previous ones. I have to replace direct rule that d square by minus a square, and if I do that, denominator is becoming 0. So I have to use the modified rule. Modified rule tells me what? I add a x in the numerator, and denominator is d is replaced, denominator is I have to differentiate, so I get 2d. Now see, I have d, I don't have a d square. Please note at this point, I have a d now in the denominator, I don't have a d square. And as per the rule, I can only replace d square, I cannot replace d. So what can I do with the d? But this is an easy case. I have d in the denominator, so actually I am having a 1 by d. So actually what I am having x by 2 and 1 by d of sine x. Okay. So now we can make use of our formula. Remember that 1 by d stands nothing but the integral operator. So see that. So I just keep the x by 2 outside. Please see, don't take x inside. X is outside. 1 by d is operating only on sine x. So x is outside, and constant of course comes outside. 1 by d is operating, x by 2 is outside here. 1 by d is operating on sine x. So that is nothing but integral sine x dx. And integration sine x we all can do. So it's minus cos x. So the answer is minus x cos x by 2. This is clear with all?
Yes, ma'am.
Okay.
Yes, ma'am.
So the first rule is failing. So I am differentiating. Once I'm differentiating, I'm getting a d, not a d square. So I'm not replacing d square by minus a square. But just because I have a d, so 1 by d is the integral operator. So simply I'm integrating and getting the answer. That's it. Okay. We will see more examples of this in next cases. But at the moment, I go to the case 4, and then we will see that again. So please see, so I have 2 more cases basically to complete. Let me do it quickly. So case 4 is actually case 4 and case 5. These are compound cases where we have product of 2 functions. So case 4, you see the xx is e to the power axv. So you have an exponential function multiplied with another function v, and v can be any function of x. There is no restriction on v. So your xx is of the form e to the power axv. What is the rule? So 1 by fd e to the power axv. The rule is again simple, that e to the power ax, it comes out of the operator. You see, it's left hand side of the operator. E to the power x simply comes out. And now fd, d is replaced by d plus a. So the rule is e to the power ax 1 by fd plus a of v. So e to the power x simply comes out, and now d is replaced by d plus a. So 1 by d plus a operates on v. This is the rule. So let us look into a question quickly. So you are asked to find the particular integral of this. So particular integral, of course, will be 1 by your fd is d square plus 1. So it is 1 by d square plus 1 operating on x e to the power minus 2x. So my pi is 1 by d square plus 1 x e to the power minus 2x. So can we apply the case 4? Yes, because you see I have an exponential term e to the power x and I have another function. So this x is now, so that v is basically x in this question, isn't it? I have x e to the power minus 2x. So this is the exponential term and v is x over here. So we can easily use this rule. Anyone? You want to ask anything, Nilanjan?
No, ma'am. No, ma'am.
Okay. Exponential comes exponential term comes out. So e to the power minus 2x is taken out. 1 by f d plus a v. Our v is x. So this will be operating on x. And what is this? Please see, the rule says that d has to be replaced by, wherever you have d, d has to be replaced by d plus a. But what is our a? Can anyone tell me what is our a?
Minus 2.
Minus 2. Obviously, it is e to the power minus 2x. So a is minus 2. So therefore, please see that d has to be replaced by d minus 2 in our case. So this is 1 by this expression. Here I will write d in place of d minus 2 in place of d. So please see, this was d squared plus 1. So d is replaced by d minus 2. So this is d minus 2 whole square plus 1 operating on x. So see that d minus 2 whole square means d square minus 4d plus 4. So finally it becomes 1 by d square minus 4d plus 5. This is operating on x. Okay. Now see, we have applied in this problem rule 4 and we have reached here. Now I have to find out it's not over. I have to find out this particular integral. And please see, here the function is x. What is x? Obviously, it is a polynomial of degree 1. X is a polynomial. So therefore, please see that we have to use what? Which rule? Now, to find it, we have to use rule 2, case 2. Case 2 was the one where we explained what we do if we have a polynomial function. Is it okay with all?
Yes.
That after applying case 4, I have to apply the case 2 because now my function is a polynomial function. So this one I will not elaborate very much because I already explained. It's the very same thing as before. Here see the constant is 5. So I am taking out the 5. So once I take out the 5 here, I get 1 plus d square minus 4d by 5. So when I write it in the numerator, please see the rest of the things are here. I have the e to the power minus 2x. 1 by 5 is the constant, it is here. And 1 plus d square minus 4d by 5 raised to the power minus 1. So once again, now I will treat this as my x. For the binomial theorem, don't confuse with this x, but for the binomial expansion, that 1 plus x to the power minus 1. So I will use that. So then I get again 1 minus of this like this. So very similarly, we have to do, and finally we will get this. Can you complete the steps yourselves? Because it's the same thing.
Yes, ma'am.
Yes.
Okay. So please do it. So another thing, just remember that actually when we have case 4, case 5 things, where we have product of two functions actually as xx, we will always need to use 2 rules at least. By one rule, I am taking out here the e to the power ax. And once again, depending on what is your v, I will have to use another rule. Because here v is x, so we have to use the rule 2. So you just follow the steps, you will get this. So I will go to the next case then. This is okay?
Ritik,
Yes, ma'am.
Ritik,
Yes, sir. Achi, sir.
One more round of attendance, last round.
Okay, sir. Okay.
Put it up and then class
Okay, sir.
will close in 2-3 minutes.
Okay, sir.
Yes.
Okay.
We are now in the last case, case 5.
Yes, sir.
So this is now, again, as I told you, 4 and 5 are compound functions, product of two functions. So this is x into v. Earlier it was e to the exponential function with v, where v can be any function of x. Here also v can be any function of x. But the form is now x into v. So what is the rule? The rule is now, see, this is, the rule is also a little bit more complicated. The most complicated, I should say, than the previous ones. But anyway, once we remember the formula, we remember the process, it's not difficult. But yes, the formula you have
Ma'am,
to
here
remember
the
carefully.
x in the right hand side is just normal x, right?
Yes, yes, yes.
Not the
It's,
function of x.
no. It's just normal x, right? So 1 by ft is operating on that. Normally we are taking capital X as a function of x, and that capital X is made up of x along with a function of v. So what is the rule now? You see, first this small x is actually coming out. First you see the expression within this curly braces. This is x minus 1 by fd. So the same operator, x minus 1 by fd. This is now operating on f dash d. You have to be a little bit careful on this formula, as I told you. First of all, the x term is coming out simply, x minus 1 by fd. It is operating on derivative function f dash d. And this entire expression in the curly braces, along with this, you have again 1 by fd operating on v. So please see, x into v, you have two functions. The x part is coming out in this curly braces, but it's not the x only. It's x minus 1 by fd operating on f dash d. And the entire thing is again operating on 1 by fd of v. So you have to remember the formula. As I told, it is complicated, but if we look it carefully, it is not that difficult also. So let us look into it. So the question here is, find the complete solution to d squared plus 4y equal to x sine x. So you see my right hand side, x into sine x. So xv, I can say that it is of the form of xv, where my v is sine x, and I have this x, v is sine x, right? So we can apply case 5. Now the complementary function, I hope all of you can do it. I will not talk much about it. It's m squared plus 4 now. So m is 2i and minus 2i. So your complementary function is c1 cos 2x plus c2 sin 2x. Mainly we will concentrate on the particular integral. So please see that. So yp, remember the formula, it was x minus 1 by fd. So 1 by fd was 1 by d squared plus 4. Your fd was d squared plus 4. Here you remember we had f dash d. So d squared plus 4, if I differentiate, it's nothing but 2d. So this expression in the curly braces is x minus 1 by fd, d squared plus 4, f dash d, that is 2d. And then I have again 1 by fd, 1 by d squared plus 4 sin x. So this is the application. This step I have applied rule number 5. Now see, it's not over. We have just applied rule number 5. Now we have to do these operations. So what I have to do? I have to calculate 1 by d squared plus 4 sin x. So which rule does it follow now? Which rule I have to use? Sin x is which rule?
4.
Not 4, it was a 3, isn't it?
3,
Sin,
ma'am.
3, ma'am, 3.
sine
Yes, ma'am.
function or cosine function. So that rule we have to use, right? So see that I'm not doing anything within this curly braces. I cannot do now anything. It's just kept. So for this part, I am applying rule number 3. Now it's easy. What was the rule number 3? That d square should be replaced by minus a square. What is A in our case? Again, A is 1.
1.
So D square should be replaced by -1 square, or rather -1. Anyway, we have written this as -1 square. So it becomes 1 by 3. So therefore, I have here 1 by 3 sin x, right? So application of my rule number 3 is now over. Once again, I repeat, this step I have applied rule number 5. This step I have applied rule number 3. So now see, I have this 1 by 3 here. So I just simplify the things. So 1 by 3 is constant. So always I can take it out. And what is your first term over here? X. So you see the first term is 1 by 3 x into sin x. So first term is 1 by 3 x sin x. Now I have to concentrate on this second term. So 1 by 3, of course, is a constant which comes out. Here I have a 2 over here. So 2 is also a constant. So that also can be taken out. So you see, I have written -2 by 3. This is the minus from here. 2 is here, and this denominator I get a 3. So -2 by 3. And what is the operator? Now there is a one step jump over here. So actually what is happening here, let me write down. I have -2 by 3, 1 by d square plus 4, and d of sin x. Everyone is clear with this? Here I have this term, you see, -2 by 3, 1 by d squared plus 4. D operator is in the numerator, d of sin x. Now d is nothing but the differential operator. So what is d of sin x? D of sin x is obviously cos x.
Cos x.
Dx of sin x is cos x. So see, we have written this directly actually. This d of sin x, this was written directly as cos x. So I have -2 by 3, 1 by d square plus 4, d of sin x. So d of sin x is giving me cos x. So I get it. Okay. Now see, the first term here is 1/3 x sin x. That is already done, nothing to be done. But here, once again, I have to use the rule number 3. Because once again, 1 by d squared plus 4 has to operate on cos x. This is actually a very nice problem. And whenever you will have actually questions on this product functions, definitely you have to use 2-3 rules, right? So 1 by d squared plus 4 operating on cos x. So again, the rule is same. So d square is replaced by -1 square. So you get a 1/3. So my final answer is 1/3 x sin x -2 by 9 cos x. Okay.
Ma'am,
And-
here first f dash d will operate over that given function, then the 1 by fd will operate over it, right?
Yes, yes, absolutely. Okay. You have to just follow the order. Actually, we are going from right to left. Whatever is the first operator, you have to operate. And then you have to operate the next. So please see, this 1 by d square plus 4 has first operated. Then d has operated. And then 1 by d square plus 4 has operated. Okay.
Now, this last rule is very, very important.
Yes.
I think students have noted, madam has said, we are going from right to left. Even if
Yes.
you talk to KBG sir, he'll tell you the same thing. We're operating from right to left.
Right to left.
So please understand the sequence. And one more thing I wanted to comment is, all of you have this book by Grewal. I think it was given in the book bank. Yes or no?
Yes.
Yes, sir.
Achha. Has anybody, can anybody confirm that this is contained, all this is contained in Grewal? Yes or no?
The last two formulas are not there in Grewal. This one is not there in Grewal.
Okay. I will
Yes.
have a look, and then I will not make any further notes because you are supposed to read the books and read this PPT when it goes to you. And before I leave, I will just mention, madam, that
Yes.
my lecture number 26,
Yes.
which I posted about 15 days back, covers part of, this FD 1 by FD business. So please go through this. And I will be leaving. Mithik, madam, can you ask Mithik to take one last this thing before we sign off?
Yes, Mritik, please take one more attendance.
Okay, okay.
Are you
Okay.
taking a screenshot, Mithik?
Yes, sir. Yes, sir.
Ma'am,
Screenshot details are take us. Okay.
Now,
PKD के साथ
students,
निकालो.
ma'am,
one
ma'am,
thing I would like to comment over here, in case if you have any doubt with this problem, because I know this is the
Ma'am?
most complicated one, please ask. And otherwise, this rule number 4 and rule, see, 1, 2, 3 are the basic rules. Whenever you have a compound function, means product of two functions, either you will need to use rule number 4 or rule number 5. So please practice rule number 4 and rule number 5 very well. Take any book of your choice. In case Grewal does not have, you can look into any other book as Paldas or any other online. Maybe you are at home, whichever book you have in your hand. Any engineering math books mostly have these rules. So please, you have to practice problems on this 4 and 5, particularly for 10 marks questions. You will mostly get questions on rule number 4 and rule 5. As you can see, they are combining 2-3 rules. So 10 marks questions obviously will be lengthy ones, and 10 marks questions you can expect to get rule 4, rule 5 questions. 5 marks questions you will get from rule 1, rule 2, rule 3, but 10 marks questions definitely you will get rule 4 and rule 5. So PPTs are shared or will be shared. So definitely look into the PPTs and try to practice problems on 4 and 5. And now I will say today not today morning, yesterday itself, I have given some assignment problems, and all those problems, mostly I think all the problems will need either rule 4 or rule 5. So please try to do those. If you are stuck up, you can WhatsApp me. I will definitely reply to you. But please try, look into the PPTs, the walked out problems. If you don't have books at the moment, look into the PPTs and our walked out problems and try to work out those assignment questions. If you have understood today's class, definitely you will be able to do them. Still, you may be stuck up with 1 or 2 problems. WhatsApp me, I will help you. Okay. Yes, now
somebody wants to say something.
Ma'am,
yes.
বলছিলাম, ma'am, that x into v, and if the function is x square, then it is a polynomial. Then we can use that method by polynomial that we.
Yes. So the next step you have to see. In this case, it was x sine x. So you had it like this. In other case, if it's like if it was something like the next step, like in fact our previous problem, second step we use the polynomial. So that can be used. Okay. And just one more thing, although I have not put a problem over here, but just for your query or your answer, this is actually case 6. There is one more rule. This is just the generalized version of case 5, as somebody of you asked for x square. So here also we have a rule that was only xv. Now we can have any x to the power nv. X to the power nv. So it can be a x square v, it can be a x cube v. And you see the rule as 5 is exactly same. Only here I have to the power n. So that will mean, say, even if it's a x square, that means this x minus 1 by fd f dash d square. That means this total operator works 2 times. Okay. So these problems are a bit lengthy when you have x square, x cube or something like this. So we have not added it. But just for your understanding, yes, if you have x power something, you can extend the rule, because then this operator gets multiplied so many times. If you have a x cube, that means this operator will work 3 times. So definitely the problem will become much lengthier, but it can be done. Okay. And one thing, if you have a x square e to the power something, in that case, don't go for this rule. In that case, go to the rule with e to the power axv. That is easier, because e to the power x comes out, and this v will remain. V means x square will remain. 1 by something, it will operate on x square. So now you can use the rule 2, the polynomial function rule, and do it. Okay. So if you have a x square e to the power x, don't definitely go into rule 5 or rule 6. Use the rule 4. Okay. Yes, any other question, or AKC sir has any other
No,
comment?
our question now about let us
Yeah,
stop
we
the
will.
class. I have a
Ma'am,
comment. I have a
Yes.
comment. K madam.
Yes, sir,
ma'am,
please.
ma'am,
Yes.
you said from right to left. Can you say that one once again? What is right to left?
Okay, okay.
আচ্ছা আমি
See,
কিন্তু বেরিয়ে যাচ্ছি ম্যাডাম with one comment that I
okay,
am
sir,
still
you can make your comment and then you can leave.
I
Then
will
I can
just make a
explain.
comment
Yes.
that you see students, these online classes take a tremendous amount of time and effort to organize, and you all are at home. I have seen the attendance. It started at 172, including Shamishta madam, KPG sir, and I, and that is at its very best, around 20%. Now it is 130 something, including 3 of us. This is rather unacceptable. I can see that only good students are here, but some students have already left. It's fine, it's their call. But in the second midterm examination and the final semester examination, unless you write your paper well, please do not depend on part marks. Part marks concept ta bhule jaan apnara. Please forget it, bhul jao. Write things properly, and I have sent a document on what is writing things properly. So please study and come for the examination. Mathematics results have been pathetic. Madam knows, KPG sir knows, I know. Thank you very much. Have a good day.
Okay, sir. I'll just answer to this question, and then we will also adjourn. Okay.
right to left এর একটুখানি বুঝিয়ে দিন।
হ্যাঁ, I'm telling that right to left বলছি। দেখো, এই যে এই কোয়েশ্চেনটাতে we had this formula. So এখানে তো I have this x minus 1 by d square plus 4 2d. This is also involving some operation. A 1 by d square plus 4. This is also involving some operator. So there are so many operators. How will you work? Now see, the function is sin x, and the function, the operator adjoint to it is 1 by d square plus 4. So we start working with this. First task, what we are doing is we are finding this 1 by d square plus 4 sin x, which we got as actually 1/3 sin x. এই স্টেপে I got it as 1/3 sin x. ঠিক আছে? এরপরে যেটা হচ্ছে নেক্সট, এই 1/3 টা তো কনস্ট্যান্ট, এটা বেরিয়ে যাচ্ছে। The first term is giving me x sin x. Let me write it once. The first term is giving me 1/3 is coming out totally. Then x sin x. 1/3 আমি পুরোটাই বাইরেই নিয়ে যাচ্ছি। I have x sin x minus 1 by d square plus 4 2d sin x. ঠিক আছে? তাহলে দেখো, these operators, এই অপারেটর গুলো এখনো রয়ে গেছে, এই পার্টটাতে নেই, কিন্তু এই পার্টটাতে আমরা একটা অপারেশন করেছি। এরপরে আবার এই যে d রয়েছে, আবার 1 by d square plus 4 রয়েছে। তাহলে নেক্সট কাজটা আমি কি করছি? I did d of sin x, তাই তো? সেটা হয়ে যাওয়ার পরে আমি আবার 1 by d square plus 4 of এই যে d of sin x করে cos x পেয়েছিলাম, সেটা করছি। তো এটাকেই বলছি, if you look carefully, we are doing the operations right to left, because first I did, এবার লক্ষ্য করে দেখো, first I did this operation 1 by d square plus 4 sin x. This was my first operation. Next যে অপারেশনটা করলাম, এই যে হয়ে যাওয়ার পরে d of that function, d of sin x করেছি। So this is my second operation. Third করলাম, সেটা যেটা পেয়েছি, I am operating this 1 by d square plus 4 on that. So you see, I have come from right to left. Right এ যে অপারেটরটা ছিল 1 by d square plus 4, this I have done firstly. Next, right থেকে left I come. The next operator was d sin x d. So I did next. After that, I'm coming to again this operator 1 by d square plus 4. So I have to operate 3 times, coming from right to left. Is it clear now?
Yes, ma'am. Yes, ma'am. Understood.
Okay. So please take care. I know this is the hardest rule. but please take care. If you understand, it's not difficult. If you have to just go it step by step.
Ma'am,
Okay.
what for the compound of three functions?
See, compound of three functions means you have to apply again the compound function rules 2 times. Whenever, say, suppose it's a good question. Suppose you have x e to the power x sine x. Okay. So one step I can apply e to the power x and v rule, where I will apply, assume that v is my x sine x. So e to the power x will come out. I am applying the e to the power x v rule. Next, you have to apply that whatever your FD operator is there, that 1 by FD you are going to apply on x sine x. So this is what just now we did. So xv formula. So if you have 3 functions, you have to use our rule number 4 or 5 2 times.
Okay, ma'am. Okay, ma'am.
So class is actually over. Students are leaving. You can leave also. But still, if anybody is having any other doubt or question, you can ask me, because we will not meet anymore. Yes.
Ma'am, in the polynomial rule, we just need to expand the function of d up to the power x consists. Like, ma'am, if the function of the x is x square plus 3 or x cube plus 3, then we need to expand the function of d up to that number of terms.
Yes, yes. If it's x cube, you go up to d cube. Whatever is the x power, so that d power up to you will need. Okay. Yes,
Okay,
Shruti,
ma'am,
you
thank
can talk. You can unmute yourself.
Ma'am, am I audible?
Yes, yes,
Ma'am,
audible.
can you
Please.
explain the right to left operator part?
Yes.
Ma'am, if
Ma'am,
we have suppose sine 5x upon d square minus 4d plus 3, then ma'am, along with d square we have terms of d. Then ma'am, how can we solve?
Okay, that's a good question. Yeah, I will show you. Just a moment. I will show you. It's a good question.
ম্যাম
Yes.
ম্যাম মৃত্তিক বলছি
হ্যাঁ বলো।
না না আমি কি একটু লাঞ্চ করতে যেতে পারি
হ্যাঁ হ্যাঁ চলে যাও ওকে
ঠিক আছে ঠিক আছে আমি
students
বলেছি
also, if you don't have any doubt, you may leave, but if you have any questions, definitely I'm there to answer you. So Shruti has made a good question. So this is something you are trying to tell, right? 1 by d square minus 4d minus 3, or it can be anything, sine 5x. And so what is Shruti's question is that what do you do about the d? Am I right, Shruti? This is
Ma'am, we have to rationalize here after putting d square minus square.
yes. So what you do first here is, I cannot do anything with d, but d square I can replace by minus 5 square, right? D square I can replace. So that first I will do. Okay. So d square will be replaced by minus 25. So basically minus 4d minus 25, and this is minus 3. So it is going to be minus 28. Okay. Minus 4d 28 sine 5x. So as someone told, it's right. We have to rationalize actually. So here we are stuck up. I cannot do anything with the d. Yes. Now 2 things you can have. The thing is that I can take out the minus 1 by 4. So this is d minus, d plus 7, isn't it? Sine 5x. Am I up right? If I take out the minus 4, I get d plus 7. Now there were 2 ways out. One way can be, you can now apply your 1 by d minus a formula. That we can do because it's a linear factor. 1 by d minus a formula you can use, Shruti. Is it okay?
Yes, ma'am.
So
yes,
that
please.
is one way out. You can use the 1 by d minus x formula. So that gives you e to the power minus 7x like that. But shorter way, that is not shorter. The shorter way will be, what we will do is we will rationalize, as one of your friend already told. I will try to bring d square over here. So what I will do is I will multiply both the numerator and the denominator by d minus 7. if I multiply both numerator and denominator by d minus 7, so numerator is d minus 7 and numerator will become d square minus 49. Okay. This is the usual way, easier way, even without using the d minus a formula. When you are coming somewhere like this, rationalize this and try to get a d square in the denominator. So it's d plus 7. I will multiply both sides by d minus 7. So d minus 7 in the numerator, d minus 7 in the denominator. So this gives d square minus 49. So now see that d square I can replace by, sorry, I had a 5x. So this d square I can replace by minus 25 again. So I will get d minus 7 in the numerator. And the denominator I have minus 4. I will, whatever it comes, you can write adding up, minus 45, minus 25, minus 49. Now what next you will do? Anyone can answer me? We are not yet
Now
done.
we will operate d
Then we will
minus
differentiate
7
now.
upon sin a.
Yes, differentiation is not a problem. So d minus 7, 5x, you will just operate that. So d sine 5x means you differentiate, you get 5 cos 5x. So your answer is going to be 5 cos 5x minus 7 sine 5x. And denominator, whatever the number you are getting, you get. So this is how you do this kind of problems. This was a good question actually. You often get this kind of questions. So whenever you have some d, keep it for the moment, replace only the d square, and then try to get d square in the denominator. You multiply something both in the numerator in the denominator so that you get d square in the denominator. Numerator d is not a problem because you can directly differentiate the function. So I hope this is okay, and particularly Shruti, is it okay?
Yes, ma'am. Yes, ma'am. I got it.
Ma'am, one thing, for the
Yes.
second mid semester,
Yeah.
would we have the entire differential equation module starting from ordinary differential equation?
No. See, I have given the syllabus in the Google Classroom. For the ODE part, you have to do 3 things. One thing is, this is the one what we are doing in this lecture. This higher order linear equations involving your complementary function as well as particular integral. This is one thing you have to do. From the first midsem part, 2 things you have to do. First order, first degree, the integrating factors, the problems where you have integrating factors. Don't do linear equation, Bernoulli's equation, exact equations. Those things are not there for the second midsem. Only practice the problems where you have to use the rules for integrating factors. There were 5 rules for integrating factors.
Yes, ma'am.
Get it? So only practice those things. Okay. And first order higher degree equations, you can get questions from that type also. So 3 things you have to do. First order, first degree. Under that, only the rules for integrating factors. Number 2, first order higher degree. Now, yes, under higher degree, you had again different cases, solvable for p, solvable for x, solvable for y, and Cloret's form. So that's any one of the cases you can get. And this part. Okay. And I told in my individual sections, I don't know if all of you know, that this time ODE portion 10 marks question will come. So any 3 of these topics, you can get any 2 questions. The 3 topics just now I mentioned, you can get any 2 questions, and of course you have to answer any one. So midsem 2, you will get 10 marks questions from ODE. 5 marks questions, I'm repeating, although I told in the class, 5 marks questions you will get from vector space and probability. 2 5 marks questions, 1 from vector space, 1 from probability. And 2 marks questions you will get from multivariable. This time multivariable will come only in 2 marks. So just practice short questions, even definition of double integral, triple integral, Jacobian, like these things, and very small constant limit things for multivariable. Practice that for 2 marks questions. Also 2 marks questions, you will get 1 from probability, 1 from vector space. But ODE, no 2 or 5 marks. ODE will be only long questions, 10 marks. Okay.
Ma'am, just asking it out of just interest. Suppose I'm getting a triple integral, and I'm not being able to decipher the geometry of that equation, but I can understand the limits. I can guess it and I can solve it to get the volume or whatever has been asked. But I cannot sketch it. So should I go for that kind of a problem?
Yes, you can go depending on the marks, maybe 1 or 2 marks. If it's a 10 marks, maybe 1 or 2 marks may be deducted or not. If it's not written directly to sketch, marks may not be deducted, or maybe 1 mark may be deducted. So, but if you are sure about the things, the limits, you can go for doing it. No problem.
Okay, ma'am.
Ma'am, for exams, we will have the power of D up to 2 or higher 3, 4. We will not get up to 2. We will get.
I didn't get your question once more. Power of
D square up to
yeah,
D
yeah.
square.
Exam you will get power of D up to 2. Practice questions up to D square problems only. Don't practice for higher. Okay.
Ma'am, should we practice double integrals?
Yes. See, for mid-sem 2, double integrals, but see, not with variable limits can come in 2 marks. Only very short questions, short double integral problems. If you open maybe Paldas
like
or
sketching the region.
The short questions that you can get, evaluation of some small integrals will come, but mostly constant limit problems will come in your 2 marks questions. Okay. And I should say, don't now concentrate much on the triple. You have to do it for the for the end sem, basically, definitely you have to do it. But for the second mid sem, again, very simple, constant limit questions only can come for the triple. Understand the definition and very simple basic concepts. Don't go for cylindrical or the other coordinates or all those things. Those things for the second mid-sem don't do. Only very simple things for the, as you know, as I told you, only 2 marks questions are going to come from the multivariable part. Okay.
Ma'am, from vector space,
marks,
we
can
have
you repeat
up
once
to
more?
Dimensions.
Yes. Vector space, you can get questions up to dimensions. Dimension,
but not from eigenvalues and stuff.
No. Eigenvalues,
transformations are not there.
No. Those things I don't think they have been taught, and you will not get up to that. Up to basis and dimension. Okay.
Okay, ma'am.
Yeah. Okay. So then, shall I close the bit if there are no other questions? And yes, if you have any doubts,
10 marks under OD, what did you say for 10 marks?
10 marks, this time only OD questions will come. 2 questions will come. You have to answer any one. As you know, there will be a OR. So 3 types of questions can come. One is from today's class, higher order equations, where you have to find both the complementary function, particular integral. So that is one kind of question it can come. The other kinds, they are from the first mid-sem portion. One is, you remember there were first order, first degree equations. You had 5 rules for integrating factors. So those kind of questions you practice. Particularly, if you remember the rule 4 and rule 5 in the integrating factors, these are the more complicated ones. So 10 marks questions, practice those integrating factor problems, but not the simple ones, maybe rule 4 or rule 5. That is the second thing which can come. And the third thing that can come is first order higher degree equations. First order higher degree equations, where we have done again 4 cases. One was solvable for P, solvable for X, Y, and Claudiet's form. So you may get question from that category. So 3 categories: first order, first degree, and that too not all, only the rules for integrating factors. That is one category. You can get a question. Second category is first order higher degree. And the last category is higher order equations, which we are doing today. Okay.
Okay, ma'am.
Okay, so then I'm closing. But yes, if you have any doubt, please WhatsApp me. I'll just respond. Okay.
Ma'am, can we have your number?
Yes, I'm just writing in the chat box. So this is my WhatsApp number. It's only WhatsApp. So write to me if you have any doubts anywhere. I will respond definitely. I think many of you have it. You do write to me. So if you don't have it, please note it down. Okay then. So I'm closing. So best of luck to you all.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.